All right, here we go for Chapter 16, Section 2, Reducing Energy Waste. We've got to learn how to reduce it, get the efficiency up. It's really what it's about. Now, there have been improvements in energy efficiency and reductions in energy waste. These could save at least a third of all the energy used in the world. In the United States, currently, about 43% of our energy is simply waste. Many technologies exist for increasing energy efficiency of industry, vehicles, our appliances, and buildings. It's a matter of getting busy, if you will, and taking care of it, making sure we get it done, if you will. Now, energy efficiency versus energy conservation. Similar terms, but a little bit different. Energy efficiency, how much useful work we get out from each unit of energy. So we take gasoline, oil, coal, solar, anything, and we can put it into a unit of energy and think, how much work do we get out of it? Cars, it's pretty easy. 25 miles to the gallon versus 35 miles to the gallon. 35 miles to the gallon is more efficient than 25 miles to the gallon. This is what we're talking about. Some things are more efficient. Then we talk about energy conservation. Energy conservation is reducing or eliminating unnecessary energy waste. This would be me putting in the better windows into my house, right? Higher efficiency. I've tried to do a lot of things. I've put in weather stripping, I've caulked things, put little insulators in my plugs using LED lights. So energy conservation, energy efficiency, using things that use the energy better, and then conservation, conserving along the way. Both of these terms are things we've got to employ, if you will, along the way. We need to look at energy as what it is, a commodity. We don't want to throw it away. We don't want to spend money. We don't have to. Now, what are some of our sources of waste, if you will? Well, poorly insulated buildings. We saw the picture of the house early on. This is a huge one. Just not insulated well. A little bit of money in insulation goes a long way in future savings. Reliance on cars for getting around. America, we get in our individual cars and go everywhere. In a lot of countries, Europe for instance, a lot of people use the public transport. People hop on the bus, hop on the train to move around in the cities. It's a lot more efficient than one person in one car when you've got a bus with 40 people on it that's making a route. So relying on cars almost exclusively is not good. We have these huge data centers, like for media servers, etc. They stay on 24/7 and they use a massive amount of energy. They put out a lot of heat. So we have a lot of energy going in, a lot of heat getting created from them. They only use about 10% of the energy that they actually consume. Awful lot of waste energy going into them. For these huge data centers, we want to make sure that we have them tied into solar or into wind power, if at all possible, because they can be really almost anywhere. They don't have to be close by this or the other. But anyway, data centers are something we really need to look at. Motor vehicles with internal combustion engines. Okay, your basic car, combustion engine. We need to move away from those, and then just our nuclear, coal, natural gas power plants. These also tend to be very heavy energy consumers as well. They give off a lot of heat, right? Heat is waste energy. It's just going into the environment, not what we're actually after. But if you look at the graphic back here, this is the idea of our energy inputs. And we looked at this in a different chapter, chapter 15, in a different way, if you will. So about 82% is coming from our non-renewable fossil fuels. Then we have another 8% coming from nuclear. This is all going to be non-renewable. So oil, gas, coal, and nuclear makes up 90%, leaving 10%, which is our renewables, right? Hydroelectric, geothermal, wind, and solar, and along with some biomass as well, but only 10%. pumps into our U.S. economy, and then what we're getting out of it, if you will. About 9% is really truly useful energy. 7% are the petrochemicals, if you will. The 41%, that is our unavoidable waste. Laws of thermodynamics. We can't get away from that, but 43%, that 43% is what you and I need to work really hard to try and recover, because that's just money down the drain. That is oil down the drain, coal up in smoke, the whole 9 yards. Some of these solutions, what can we do to improve energy efficiency? Or if we improve energy efficiency, what does that do for us? Well, number one, it prolongs a fossil fuel. The longer we have them, then we have them for the rainy day we can tap into. We want to stretch them out as long as we possibly can. It reduces our oil imports into the country. If we don't have to rely on importing oil for our energy, that actually gives us energy security. We want to be able to control our own future, not have it up in the hands of someone else that controls the oil. We need to control our own energy future. Very high net energy, okay? If we're talking about energy efficiency, the more efficient we get it, then we get a higher net energy. That's what we're after. We don't want a low net energy, we want a high net energy. Energy efficiency is what's going to get us there. It's low cost, right? The more efficient something is, the lower it costs. 25 miles to the gallon, 35 miles to the gallon. It costs less to drive a 35 mile to the gallon car. It costs a lot less to drive a 100 mile to the gallon car, right? Want to get the efficiency up. It reduces pollution. The efficiency, that means the energy is going directly into what we want it to do, cuts down on pollution, and it also creates local jobs. When we're doing things that creates jobs for people, these are all things that we are after and we really should be after. Now, along with this, in improving our energy in industries and utilities. So, there's some things you and I can do at the house, right? And we need to do that. But a lot of things have to be done out there, right? It belongs to the energy company or industry. I don't necessarily have control over what's happening at some random warehouse, but people working there do, or the owners of it do. So we need to have things in place there. One is cogeneration. Now in a power plant, right, we're boiling the water to create the steam to spin our turbine. Spinning the turbine, we get our electricity. Well, we have this hot water, right, that we have to get rid of. Well, if we pipe that hot water through the walls, we can warm the building. This is cogeneration. Taking this waste energy, but using it for something else. Combining both heat and power. Two energy forms from the same fuel source. We burn the thing, heat this up to get electricity, but then we can also take and use the hot water for another purpose. This is cogeneration. Some countries and places are much better at using it than others. We need to replace our energy wasting electric motors. A lot of our electric motors of today are much better than older models, and they just need to be replaced. We need to get things in with higher efficiency. They're there and they pay for themselves very quickly. Yes, we have to buy it up front, but we've got to look at the long haul. Recycle materials uses less energy when we recycle instead of getting it from ore. We need to switch our lighting to LEDs. They are much more efficient. They're like 90% efficient compared to an incandescent bulb, and they're even a lot more efficient than fluorescents. So switching to LEDs, less heat, more energy, it saves all the way around. We need to make sure our energy use, so we know what it is. And keep track of it at all times. No matter where it is, we need to have a meter on it so that we can monitor and keep it. That way, if there's a problem, we notice it right away. And we need to shut down anything that's not used. You leave a room, turn off the lights. You go to bed for the night, shut everything down. Don't leave it on standby. Have it on a switch so you can turn the whole thing off. Like I said, I plug everything into one thing. My TV, everything goes into this one thing. Then when I'm done for the evening, I shut the whole power down. So it's not sitting there on standby. We need to shut everything down. Oh, when we all do this, it makes a big difference. We also need to build that smarter and more energy efficient electrical grid, like we talked to. Our current grid is outdated and incredibly wasteful. It's old, it's very old technology. Many of our developing worlds have better energy grids than ours. They're leapfrogging. They didn't have one, and now they've learned what to do, and they're putting in a better one in place. We've yet to go back and root out some of our old technology and put in new because it's just there, and we haven't bothered with getting it done. We seriously need to do this because our current grid can get overwhelmed much easier than new smart grids. In new smart grids, we don't have power outages going down as much anyway. It's something that we need to address. These things use ultra high voltage. They are super efficient with their transmission lines. They are digitally controlled, so we can shut it on and off and move the power around much more effectively. They respond to local changes. When we have more power needs here, the power can shift to it. Guys, when you and I aren't at home, we're not using a lot of power in our neighborhoods. But out in the business district, the power is way up. And then what happens at 5 o'clock? The power goes down from the district, and well, we need to be able to shift these power needs around, and that's what a smart grid will do. It also makes it a lot easier to buy renewable energy. This is where all of us put a solar panel on our roof, and we can sell that renewable energy. One of the smart grid allows it to do that. Our current grid doesn't really encourage that so much because it's not built to do it. We need to switch to grids. Many countries already have, many countries are. The United States is honestly seriously lagging in this endeavor because our infrastructure is old and we haven't gone through to rebuild it, but it needs to be on a federal level, nationally, if you will. Now, when we need to make our transportation also more energy efficient, we talked about our dependence on cars is a lot. There's a lot of hidden cost in gasoline. The government subsidies and tax breaks for the oil companies make gas seem unnaturally cheap. Right now, I'm not sure. I don't buy gas. My car doesn't have gas. Last I looked, it was like around $2.50, $2.75 a gallon. Well, it really should be more like about $12 a gallon if you took all the subsidies out and the tax breaks. I don't want to do that because then people are not going to want to buy as much oil, which is what they're after. They're trying to sell oil, and they don't want to do that. The prices are really actually lower than they should be, and we need to have full cost pricing. If it costs that much for gas, then it costs that much for gas. You and I are going to wind up buying vehicles that use less gas or no gas, and a lot of the companies really don't want that to happen. We need to build or expand our mass transit and some of our high-speed rails. Now, Elon Musk has been doing a lot in this endeavor in both, whether it's electric cars, Tesla, or some of his rail trains, but we need to do this in a much bigger scale. We need to adopt public transportation. Quick, efficient, and it's actually easy to get around. Right now, we have such an individual, I want to drive my own car. A lot of countries just don't do that. They walk, they hop on the bus, or take a bike. We tend to drive a car everywhere we go. Mass transit, and even rail from city instead of flying. Rail is much, much more efficient, but we don't have the systems in place currently. Actually carrying more freight by train instead of trucks. Once again, our individual with trucks going everywhere. Rails are much more efficient. We should get more done with it. And we actually want to encourage bike riding. Get out there, walk to school, ride your bike to school, walk that. But to do that, we really need to build the bike lanes so people feel safe in doing it. Gainesville is a great town because we do have bike lanes everywhere. It's one of the things I love about this town. And I get out and ride my bike a lot, but not everywhere does. Building bike lanes is not that big of a deal. You paint some lines on the road. It's not, rocket science, but we want to make sure we get it done. We need to switch to energy efficient vehicles. We have really got to wean ourselves off of the trucks and SUVs. Once again, gas prices are really lower than they should be, and people then tend to waste what they see as being cheap. Now, some of the gasoline hybrid electric cars, they've been incredibly popular. Prius, just to name it as a name brand, but people are very familiar with it, and it's been wildly popular and hugely successful. Now you have two different types of hybrids in a sense. Put the picture up. One of them has a little bit larger fuel tank, you put in the gas, and a smaller battery power. And the gas runs the battery to run the car. We get much better gas efficiency. So the car tends to run on battery until it needs an extra oomph, then the gas kicks in. Now the plug-in hybrids have a much smaller fuel tank and a larger battery. So you plug in the battery and the fuel tank runs to continue to charge the battery. And then of course you have all electric vehicles. These are completely battery charged. You plug it in, these things run from anywhere from 80 miles to 300 miles on a charge now. You can plug the thing in overnight and then you're good to go for a week. My car, I drive it all week long. I go home, I plug it in overnight, typically on a Friday night, wake up the next day and it's good for the rest of the week. I'm fortunate that there's a free plug right across the street from me. So I go home, I run across the street, plug it in there and pull it off of the grid. But, all electric, battery powered. And then we also have hydrogen fuel cell. We'll talk more about the hydrogen fuel later. Hydrogen gives a lot of energy. There's a lot of pluses to it, but there's also some negatives because currently it's a negative use energy source. It takes more energy to create the hydrogen than the energy we get out of it. But maybe one day if we come up with better ways to get hydrogen. And we just need to make the cars lighter, more efficiency or conservation, right? The lighter the car is, it doesn't take as much energy to make it go. So using some of the materials, like my car, there's no metal in it at all. It's all carbon fiber and plastics. Carbon fiber give it the strength, and then plastics was making it a lot lighter, therefore you get a much larger use out of it. Along with these electric cars and hybrids, etc., comes for the search for better batteries. Our battery technology has come forward in leaps and bounds. We've gone from our nickel-cadmium batteries up to our lithium-ion batteries. And the lithium-ion batteries they're light, they're very energy dense, etc., but they do wear out. They kind of have a life cycle, if you will. They can only charge and get recharged so many times, and then you start getting less and less and less out of them, and eventually they would have to be replaced. So this is our biggest hurdle. Now we've come a long way, we're just not exactly where we need to be yet. We're looking at some things utilizing nanotechnology. Once again, amazing field of science, all kinds of things coming out with nanotechnology, and batteries, one of the big ones. There's been some development of zinc air batteries. These things last much, much longer, can have a lot more chargers, and even looking at technology using supercapacitors to transfer the energy quicker. Talk about a field to go in right now, battery engineer. It is going to do nothing but grow and grow and grow in the future, and boy, do we need better batteries than we have right now. The field has exploded, and I cannot wait to see what the future holds in the terms of batteries. We have so much research going into it right now, it's bound to just blow our minds with what they're coming up with. Now, buildings. We talked about energy, we've talked about cars, buildings. Now, we've seen a lot we're losing is green architecture. These like living roofs. Typically a roof is all dark and black with a tar. Well, we've learned if we put plants up there, well, that green, it reflects the light. It doesn't absorb it as much, and that soil and all the plants and everything else, it provides an amazing ability of insulating the areas below, keeping it much, much cooler. Using sometimes kind of specially formulated soil and vegetation. We don't want it super heavy, right? But we found that having a green roof actually has tremendous insulative benefits, if you will. We're also looking at building some buildings what we call super insulation. And when they have the super insulated building, everything stays trapped inside. They almost, even in cold areas, they have almost no need for heat. Body heat alone tends to warm them up enough. Now, one of these, if you're looking at here, this is a hay bale construction. literally straw bales put in now because they're pretty thick. It's incredible insulation. You build with that and then you put your building materials on both sides of it. It creates a super insulated building. Now you got to make sure you're using double or triple paned windows. They typically put vacuums in between. But these super insulated buildings, it takes very little energy to heat or cool them, and a lot of times in heat, it's not, as long as you have people inside of there, you don't even need heat. They stay incredibly warm. We're looking at things with this super insulation, and the U.S. Green Building Council Leadership in Energy and Environmental Design, otherwise known as LEED, are really trying to put standards on the market more so we know, like, is it energy compliant or different things, so we know what we're getting or what we're buying. Because a lot of times you go to buy a house, and the difference in this house is, wow, this house is $50,000 more. Well, it's got $50,000 worth of insulation and different things, which are going to save you loads of money down the road. So sometimes it's not the price tag we see on the outside, it's what went into the house and how energy efficient it is for, the 30, 40, 50, 100 years the house is going to be standing there. Another avenue we need to look at is air conditioning. Now, air conditioning is a huge draw on power, and it tends to affect climate change. There are over 4 billion air conditioning units are going to be added to the planet in the next 30 years. 4 billion more units coming online in the next 30 years. This is a lot. Currently, right now, air conditioning is concentrated in the United States, Japan, and China. Most of it is. Most of the world doesn't use air conditioning all the time. We're accustomed, you go in, if you turn the air conditioner on, is it cool enough? We have air conditioning everywhere in the United States. This is not normal in most of the world. It's expensive, and it's just not necessary in a lot of times. You can simply adapt to a slightly warmer temperature in a room as you're used to it. We're just accustomed to air conditioning, and we use it all the time. Use of air conditioning is going to rise, though, throughout Asia, Latin America, Africa, and Middle East. Once again, as people get more affluent, they have disposable income, they begin using more and more air conditioning. And once again, air conditioning is a huge draw on power, and it tends to contribute a lot towards climate change, releasing some of the gases. When we talk about saving energy and money in our existing buildings, well, how do we go about doing that, or how did you or I going about saving money in an existing building? It's one thing to build one that's a superconductor and all this stuff and amazing insulation, but I live in the house I live in, right? I can't just go tear it down and build a new one. I can't remotely do that. So what do? Well, you can get a home energy audit. You can have somebody come out, they'll take thermal imaging of your house, kind of see where the leaks are, and then you can know exactly what you need to do to fix it instead of thinking, well, I'll try this, I'll try that. But first off, make sure the building is insulated. You have insulation in the ceiling and your roof, your walls, whatever you can, and plug any leaks that are there. And talking about plugs, literally your plug, where you plug in, if you pull that open, usually it's just open air and a lot of heat can leak out from there, and you can buy some very simple insulators to protect those. You want to use energy efficient windows. A lot of single pane windows, these are terrible. These double pane windows, and a lot of times they fill them with argon or some other noble gas, or they make it a vacuum. They suck everything out. And these things are incredibly good at insulating. The heat doesn't go out or the heat doesn't come in, depending on which way you want it to be. Energy efficient windows, a huge way to go. You want to stop any kind of heating or cooling loss that you have. You want to have insulation around your ducts. Notice any holes, any gaps. This is where that energy audit really comes in. So we want to make sure everything is as efficient as possible. Make sure your water heater is insulated, that it's being efficient, and use energy efficient appliances, computers, and lighting. Please, please, please make sure you're using LED lights in your house. They have come down in their prices tremendously in the past 5-10 years. They last 25 times longer than a regular incandescent bulb. Really need to be using LED lighting if at all possible in your situation. Now, Energy still remains artificially cheap. Subsidies, tax breaks go into it, and it keeps our energy artificially cheap. And because they don't include a lot of the true costs, especially when it comes to the environment, if you will. There are very few large and long-lasting incentives for improving energy efficiency. We really should have much more. If you want to buy energy efficient windows to put in your home, there should be something to help you do that. Some way to make it much easier to do it, whether you can kind of buy it on some kind of credit that goes in, it can come off of your electric bill, something. But we need to have ways to help people put in energy efficient appliances and units and insulation, because it actually saves us all in the long run. Now, a lot of times people talk about there's a problem of this rebound effect. Well, if I'm saving money, then they pivot away. Well, I got a car that uses a lot less gas, so we can go on more trips. Now, most of that doesn't last real long, and a little bit of education along the way goes a long way. One of the reasons that renewable energy is not more prevalent kind of comes down to this. Inaccurate perceptions about solar and wind energy. A lot of people, oh, they're unreliable, or they're intermittent, they go off and on. They're part of the energy source. They come in, and just like everything else, the more we can get from solar, the less we have to use from something else. There's always going to be a bit of both. We want to use everything we can. But it's this idea that they're not very reliable. They're incredibly reliable. The technology in the past 10 years has just quadrupled in its efficiency. Anyway, a lot of people still think they are. The government subsidies and tax breaks tend to lower they're lower for renewable energy than for fossil fuels. It really needs to be the other way around. We already know how to go about fossil fuels, do the fossil fuels. We don't need more research into fossil fuels. We need more research and tax breaks into the renewables. That's what's underway. But once again, remember, it takes about 50 years to go through a transition, and we're in the middle of it, or maybe on the early end. So eventually some of these things have to switch. We need to put our money